talking about things like scatter plots, lines of best fit, correlation. All of those words should have heard before, correct?
Yeah.
Yes, kind of, maybe. Okay, so we're going to look at this in a little bit of a different way. Okay, go to the next screen. How many fast food hamburgers do you eat in 1 week?
None.
Put your answer right down here.
I don't even know.
It's gross, man. My answer would be 0. I don't do fast food.
Actually, I don't eat hamburgers. I get like McDoubles.
Oh, so that would be like
Not
2
even
and 1.
Right. My mom coaches.
Okay, so that's 2 and 1. So let's say you have 1 a night, so that'd be 10 hamburgers.
Right, I don't have one a night. I have it maybe 2 times a week.
Okay, so 4, because that's 2 patties, right?
That doesn't include lunch though. Oh, I don't see when you guys get to go out to lunch.
Okay, so how many fast food hamburgers do you eat a week? Put your answer there. You ready to go?
Yeah, I guess.
All right, so how do you think the number of grams of fat and the number of calories are related? Okay, directly. Give me more than that. What do you think happens as we get more fat? What happens to our calories? Calories are going to go up. Okay, so I want you to just give me an idea of what you think happens when number of grams of fat goes up. What happens to our calories? What do you think? Type it in there. Yeah, good. So type it right in there. Okay, so did you guys have your answer down there? We're good to go?
I don't know.
Okay, so you ready? You guys ready? On the next page, we're going to see a table that talks about the number of calories and the number of grams of fat. What I want you to do is I want you to look through this table and see if you can find a relationship between that fat and the number of calories. See if it's direct. See if it's inverse. See if it goes up by a certain amount each time. So I want you to just peek through the data and see if you see a relationship. Now you have more data than I do up here. For some reason the side of my screen is missing. I haven't been able to correct it yet. So you'll be able to scroll down. Okay, so just take a minute to look through that data and see if you see any relationship. Okay, so do you guys see any connection between the values for fat and calories? What are we noticing about the values for fat compared to the values of calories?
The more the fat, the more calories.
The greater the fat, the greater the number of calories. Now we do have a couple of values where it doesn't show that it's direct, like we talked about with variation, correct? Look at 11 and 270. I also have that value for 9. So sometimes it's going to depend on other variables like the quality of the meat or the fat content, and some of those things may shift, okay? Also things like what you're putting on it, like massive amounts of cheese or nasty bacon. So yeah. Okay, you're welcome. All right, so on the next page, you guys ready? Next page. What we're going to be looking at on the next page is a scatter plot. Scatter plot, you guys know, is just pieces of data that are plotted on a graph, right? What we need to look at is how to organize this data. All right, so what we're going to do is we're going to look at the x-axis and we're going to make that our fat. We're going to look at the y-axis, we're going to make that our calories. So we're going to organize our data. Once we've done that, we're going to put in something called a movable line. You guys heard of the term line of best fit? Okay, so that's what we're going to be looking at. So go to your next page. See how it's all just data plot down there? All right, so go down to the bottom where it says click to add variable with your cursor. And you're going to choose fat. See how it moves your data? So now what it's done is it's organized it only by its fat content. Okay? Come up to the y-axis. You're going to click over on here. Notice it's not there anymore, but it is there. You just have to scroll until you see the little box. Okay, you're going to click there and you're going to choose calorie. And it's going to organize that data according to its fat and its calorie content. Okay, so just by looking at this scatter plot with our data arranged like it is, what kind of features can you tell me about these points? What do you see here? Positive correlation. Very nice. Perfect. What else do you see?
What's positive correlation?
We're going to talk about that in just a second, Marissa.
I'm not as smart as her.
What else do you see?
Not negative correlation.
Not negative correlation. Okay. If I were to put a line in here, what kind of slope would it have? It would have a positive slope. Good. Do I think I can put a line in there that comes pretty close to everything?
Yeah.
Okay, so what we're going to do is we're going to try that right now. Hit your menu button.
Can it be a thick line?
It's going to give you only one line option.
I guess it can't be.
Okay. We can't put a huge line that touches everything. It's just going to be one line. Okay, so what we're going to do is we're going to go to menu, we're going to go down to analyze. The first option it gives you is add movable line. I want you to click on that. Did it put a line on everybody's scatter plot?
Yeah.
Okay, now what I want you to do is I want you to shift this line around until it looks like you're close to every single point, or you have the same number above the line as you do below the line. So you're going to shift this line around. The way that you do that is you grab the bottom of the line and you move it. You can grab the top of the line, you can move it. You can grab the center of the line and move it. However, you can get it so that you think you're as close to as many points as possible. Okay, so take a minute to do that. Notice this equation right here. The equation that was down in the corner. That's your equation for your line of best fit or your movable line. So when you move that line around, you should also see that equation changing. You're changing the equation of the line when you move it around on the scatter plot. Okay, so take a minute to do that. You guys have your movable line in?
Yeah.
All right, just take out a piece of paper, and I want you to real quick write down the equation of that line, because you're going to put it in on the next page. Okay, so just sketch it down very quickly. All right, so once you have your line of best fit, that equation sketched down, I want you to go to the next page and write your equation right down here. Okay, does everybody have their line of best fit typed in there?
Yeah.
Okay, once you have your line of best fit typed in there, just go to the next page. All right, so question is, why does it make sense that the number of grams of fat is used as the independent variable? Now, remember, where is the fat grams located on the graph? Is it X or Y? X. So X is called your independent. Y is called your... Okay, so why does it make sense that fat is used as independent?
Because the amount of fat that you take in.
Right. Okay, so the way we can look at this is, notice we're starting with fat, right? And fat, depending on how many grams, is going to change the number of calories, correct? Mm-hmm. So the number of calories depends on the number of grams of fat. Does that make sense to everybody? Mm-hmm. That's why we call calories are dependent and fat are independent, because it's affecting everything else instead of being affected. Does that make sense? Okay, so in your own words, you're going to put down why that is. Why is it that we call it independent instead of dependent? Okay, so the next page it says, what does the slope mean in terms of grams of fat and calories? So looking at our movable line, we said it had what kind of slope? What does that mean in terms of fats and calories? Perfect, Dan. Say it again.
As fat increases, calories increase.
As fat increases, calorie increases. Good. Type that in. Okay, so let's move on to the next one. On the next page, we're going to see another graph of data. From the actions menu, we're going to select regression and then show linear. Okay, so what this means is we're looking for a regression line. What a regression line is basically the best line of best fit that you can possibly get. Okay? Throughout this year, we're going to be talking about linear regressions, exponential, logarithmic, quadratic. So we're going to be talking about all different sorts of regression lines. This is very important. They usually show up 2 to 3 times on Regents exams, and they're usually heavily counted problems, 6 points, 4 points. Okay, so this is big. You need to pay attention to regressions. Okay? So go to the next page. Who remembers what it said to do?
Regression.
Menu. Analyze. Not add movable line. Regression. Show linear. And it puts it right in there for you.
What's show linear?
MX plus B. And here is your regression line. Oops. Yes. Control Z. Okay, so there's your regression line. This is the best line you could possibly put in there for the data that we have. Okay? This equation allows us to plug in values and get other values out that would simulate the data that's here. All right? For example, if I look at this piece of data right here, it's the point, it's 23, 510. If I were to plug 23 in for X, I would get 510 for Y. Same thing here. If I have 43 and 660, if I plugged in 43, I would get 660. This is what this equation does.
You did
Okay.
exactly that?
Exactly. Okay, so, well, maybe it may be off by like 1/100. Okay? Alright, so go to the next page. Eventually. Compare your equation from your movable line with your regression line. How close were you? Were your slopes different? How were they different? Were your y-intercepts different? How were they different? So I want you to compare and contrast the regression line to your movable line. Okay, so we put down our differences, how we differ from our movable line. Let's look at the next one. What does the y-intercept mean in the context of this problem? Y-intercept.
Where the line crosses the y-axis.
Where the line crosses the y-axis. Good. What does that mean? Think about what we're talking about. We're talking about fat and calories, right?
Where's the zero?
Where what's zero?
The fat.
Okay, it's where the fat is zero.
And so it's calories.
Are you sure?
Oh.
Y equals mx plus b. What was our y-intercept for our regression line? It was kind of high, wasn't it?
Yeah.
What was it at? About 100 something?
40,000 something.
156.
Yeah.
156? Okay, so when I have 0 grams of fat, I still have calories, right? So what does that tell us?
But they're not a direct.
There's no direct correlation there, sure, but what is it telling us about the food we eat? Do we have to have fat in order to have calories?
No.
No. Think about celery.
That's negative.
Celery doesn't have any fat. It's got calories, but it takes more for your body to eat the celery. What's the word I'm looking for? It burns more calories to eat it than it actually contains.
What about when you add peanut butter?
Peanut butter's different now. You're adding fat to it. Okay. All right. So what does the y-intercept mean in the context of this problem? What did we decide? What does it mean?
Zero.
Yeah, when our food has 0 fat, it's still going to have calories. Okay. Good. So get that in there, please. All right. So let's look at the next page. Based on the regression equation, how many calories would a hamburger have if it has 22 grams of fat? That's what? X or Y? X. It's on our x-axis, remember? So you have a regression equation. Y equals, I don't remember.
X. And X plus B.
Well, yeah, but what was the actual regression equation?
12.1432 X plus 156.78.
Okay, so here's our regression equation, right? I want to know when there's 22 grams of fat, how many calories do I have? So what am I looking to do here?
Are you going to substitute X for 22?
Good, you're going to substitute 22 in for X. Now down here is a calculator page. Okay, on the bottom half of this page is a calculator page. So what you're going to do is you're going to put in your regression equation. You can't put in a Y equals. Not putting in Y equals, you're just putting in the second half of the equation. So 12 point whatever it is times 22 plus, and you should spit back out a number for calories. What'd you get for a value here?
423.9.
Okay, so this is how many calories you get out of a hamburger that has 22 grams of fat. A lot, right?
Is
Okay.
that like McDonald's hamburger? Is that like one you make yourself?
22 grams of fat, I'm guessing McDonald's.
How am I cooking that? I mean,
44 for you since you double ones.
That takes out fat. Does it really?
Okay, go to the next page, please. You ready? Based on the regression equation, how many grams of fat would predict a 1,243 calorie hamburger? Now we're talking about calories. What value? Y. So you have to plug it in for Y and solve for X. Okay, so go ahead and give that a shot. Okay, so did you guys get a value?
No. Yeah, I got.
Okay, please stop talking and listen. All right, somebody tell me your regression equation, please. Okay, here's our regression equation, right? For Y, we put in 1243, correct? So you should have subtracted over 156.787. Okay, what did you get when you subtracted that over?
1086.21.
1086.21, and that equals 12.1432x. Next step is to divide by 12.1432. And you got x equals
89.4.
so a hamburger with 1,240. Huh?
I got 0.3.
Whatever. That's fine. It's close enough. All right. So 1,243 calories is going to give you a hamburger with about 89 grams of fat. Does anybody know how much a McDonald's hamburger, how many calories it has? I think they usually sit around 1,200. Pretty close to that. 89 grams of fat.
Rice was at 3,000 calories a day.
I definitely go with
Yeah, I would say.
So, do we see how we can plug in values to get other values out? Do you see how we can use the equation? This is the important part. I hope you're listening to me and not talking about things you don't need to be talking about. Do you see how we can substitute in values to get other values out? That's the important part. Okay? All right, so let's look at the next page. Which of these statements is true about a relationship between the number of grams of fat and the number of calories? I want you to read through them and select it. Let's see if you get it right. We have two answers for this. We're dealing with B and C here. Is the number of grams of fat increase, the number of calories increase, the number of fat decrease, the number of calories decrease. Okay, robotic flavor over there. Let's try the next page. All right, so for situations in which one variable increases,
I'm sorry.
all right, so if one increases and the other increases, this is what we call a positive correlation. Kat already said the word correlation. Correlation means relationship, okay, how they interact with one another. And in this case, it's positive. As one increases, the other increases. Does that make sense to everybody in here?
Yep.
Okay. Same thing, if one decreases and the other decreases, that's also positive correlation.
How's it so positive?
If one decreases and the other also decreases?
Wouldn't it be a negative correlation?
No. If one increases and the other decreases, it's negative. If they both increase, it's positive. If they both decrease, it's positive. If one increases and the other decreases, it's negative. Think about it when you like multiplying integers. Negative times negative is A. Positive times positive is A. Positive times negative is A. You see?
Oh, okay.
All right, similarly, negative correlation. You might also see it written as association. I don't use that term, and I don't think the Regents exam will either. So the word I prefer that you know is correlation. Does anybody know when we're dealing with correlation, what numbers we go between? 1 and 10. Okay. We need to backtrack. Enter a notes page, please. Control I, add notes page, please. Okay, type in correlation. Okay, when you're dealing with correlation, it goes between -1 and +1. So you're going to do -1, control less than, that's not what I wanted, control less than, x, control less than 1. It's underneath your equal sign. Okay, it goes from -1 to +1. All right, that's when we're dealing with correlation. When you're going between -1 and 0, this is where we're going to be dealing with negative. And similarly, when we're going between 0 and +1, we're going to be dealing with what? Positive. I guess this, you know what, guys? This, instead of less than or equal to, that should just be less than. I apologize. I didn't think about that ahead of time. Okay? The reason it's less than and not less than or equal to when you have 0, this is no correlation. And I'm going to shorthand because I'm lazy. So 0 is no correlation. Yeah, did I only have one R? Of course I did. You guys know I can't spell. This is nothing new for you. Okay, I'm just shorthanding. Alright, so I'm going to draw it in here. I just want you to keep this in mind. If we're dealing with a negative correlation, you get something that looks like this. Negative slope, points somewhat close together. Positive correlation, like this. What do you think no correlation is going to look like? They're all over the place. Okay, with no correlation, you're not going to be able to get a line in there that's going to give you a line of best fit. They're all over the place. Okay, the closer you are to 1, the better the line of fit. It means that if you have a correlation of 1, you're dealing with a line. Okay, if it's 1, you're dealing with a line. If it's -1, you're dealing with a line, but it's negative. Okay, the further you get towards 0, the messier it gets. Does that make sense to you guys?
Can you say that again so I can?
I don't remember what I said.
The correlation only has one L. The closer you are to 1, the better.
The closer you are to 1, the better the
Accuracy?
yeah. The better the line of fit.
Okay.
I still don't understand what correlation is.
Correlation means relationship. So how do these points relate to one another? Can you put a line of best fit in? Correlation just means how they relate. It's their relationship.
So can't you say, like, what's your correlation with someone else?
Right.
If you're related.
How do you correlate with this?
Is it the closer you are to 1 and -1?
Yes, the tighter the correlation, the better the line of best fit. So the closer you are to positive or -1, the better the line of best fit. All right,
One more time.
the closer you are to 1 or -1, the better the line of best fit. Okay. Are you ready? All right, is the relationship between the number of grams of fat and the number of calories positive or negative correlation? Positive, and I'm just going to put a plus sign because it's easier. Okay? It's positive correlation. When one increases, the other increases. Okay, that's the end of that document. When you're done with it, you're going to open up 6B, please. What we're going to talk about now is absolute value equations. You guys all know what absolute value is, right? If I asked you what the absolute value of -5 was, you tell me. If I asked you what the absolute value of 5 was, you tell me. Okay, it's the distance from 0 on the number line from the origin. Literally that. The distance from 0 on the number line is the absolute value.
Isn't it like the absolute value of a negative number, except the absolute value is always positive?
Yes.
And then if it's a positive number, then it's still the same?
Yes. Okay, so what we're going to be looking at today is their graphs. We do need to do a little bit of changing to this document, so you're going to have to change a couple things in here. Okay? All right, so let's look at the next page. All right, the pages that are going to follow this, what we're looking at is we're looking at absolute value graphs with a point which is the vertex. Vertex means where it comes to a point, and then 2 rays that come off of that point. So can anybody tell me or describe to me what an absolute value graph looks like? No? Kind of like an angle? Like a V. Good, it looks like a V. Okay? So it includes a vertex, which is the point, and then 2 rays that come off of it. All right? So what we're going to be thinking about is we're going to be thinking about the slope of the rays. We're going to be thinking about what the vertex point is, how it's shifting up and down on the X and Y axis, how it shifts over. Okay? Now, I want to change this form a little bit. I don't like the way it's written. So what I want you to do is go down here, and you're going to put a new one in. So delete it, and we're going to start new there. You're going to put in, I'll show you what you're going to put in. You're going to put in, that's a T. I don't know why she's
Get
doing
rid of
that.
that equation?
Yes, please. Y equals. Who knows where I find the absolute value template?
The book.
The book. Go to the book. It is in tab 4. To get over to tab 4, just hit 4. And it's all the way over on the top to your right. Once you click on it, it will enter it into your notes page. Okay, so what you're going to put in there is you're going to put in mx plus b. And then outside of it, you're going to put plus c. Okay? We okay? All right, so I want to enter one more thing, so hit enter. Go down to the next line. Type in vertex. Come on. You ready? Fraction template. Negative b over m. Over. Comma. C. Close parentheses.
Those only parentheses there.
You didn't have to open it. It automatically puts it in when you close it. Okay? So that's what you should have. Negative b over m, comma, c, in parentheses. What this does is it describes to us the pieces of the vertex. Okay? M stands for slope. You'll see what C stands for in just a minute. Does everybody have that in?
Yeah.
All right, so let's...
Vertex going to be a pair of coordinates, is that why it's...
The vertex is a coordinate, yes. Okay, so let's look at the next page. After the equation, alter the equation in the text box with the chosen values of, we're doing M, B, and C instead of A, B, and C. And drag the text box to the axis to display the graph. If the graph appears to coincide, verify your equation is correct by substituting coordinates of the original vertex and the point. Okay, so let's look at it. We have more? Go to the next one. Okay, go to the first graph. Are we here?
Yep.
All right, so we have this nice absolute value graph, right? So we need to write down some information. First thing I want to write down is what the vertex is. What is the point for the vertex?
How can we do that?
0, 3, 4.
0.
4.
It's going by twos.
Oh.
So 0, 4. This is the vertex. It's a point on the graph. Okay?
Is there a way like we can write on our thing or...
No, but you can add a notes page and do it on the next page. Well, you know what? Yes, there is. Let me see. Menu, actions, text. And you can add a text box and type right on there. Sorry, I didn't even think of that. So menu, actions, text, you can put a text box in and type this in there if you want. Okay, so I can say my vertex equals, what did I just say? 0, 4.
Is that a 3?
No, it's 4. Goes by twos. 2, 4, 6, 8. Okay, so there's my vertex, right?
Miss, could you want me to write?
Just click enter, and then click in a new spot. And now I want to know what my slope is. So I'm going to look at my rates. What is my slope equal? Here's a ray. Remember, slope is what?
Yeah, mine just
Rise over run. Okay, hold on. I'll help you in a second. Rise over run. How many am I rising? 2. How many am I running? What's 2 over 2 equal? So what's my slope? 1. Okay. Ready? You guys ready? All right, so now we know that the general formula for what we're using is y equals the absolute value of mx plus b plus c, right? I also know that I have something specific for this vertex. We gave an equation that said, where is it? V equals, and then I had, negative b over m and then C, correct? Not 2, just 1. Okay, so this was what I had. This is what my vertex is. Now, if you want to move stuff around because you don't like where you've placed your text boxes, notice this up in the corner. That's telling me that I'm still in text mode, okay? Hit escape to get out of it, and then I can move around what I need to move around. Okay, you see how that works? Is everybody okay with that? All right, so now, look at what we have. We have the vertex. We have the way I set up my vertex. It's telling me automatically what C is. What's C? 4. What's M? 1. Okay, so we've got C, we've got M. The last thing I need is B. Here is B. B is sitting over 1, correct? If this is my point, if it's 0, what would B have to be in order to make it 0? 0. All right, so let's look at my equation again. I'm going to put in my text box again. Actions 6, and I'm going to write it out. All right, so I had y equals. Then I had the absolute value. It's not the one I wanted. Y equals my absolute value. And what did we say M was?
1.
1, and I had an x, right? What did I say B was? Do I even need to put it? No. Okay, so I'm going to get out of my absolute value by hitting over. And what did we say C was? 4. Here is my equation for my absolute value. Do you see? Yes, dear. No, you don't need the 1 either. You could just have the absolute value of x plus 4. That would work as well. Okay? Now, let's notice something about this. Where on this x-axis does the vertex lie? 0, 4. 4. 4. So what do you think that value of C is going to do to your absolute value? It's going to move it up and down on this y-axis. Very good. Okay, so that value of 4, when I go up, it's going to add. When I go down, it's going to, do you see? Okay, so let's move on to the next one. We're going to start looking at what B is going to do in a couple of minutes. What do you think B is going to do? Instead of going up and down, it's going to go
Left and right.
Okay, so we'll see that in a minute. I want you to try the next one, see if you can get it.
So what?
Okay, so somebody, can anybody tell me what this equation was just by looking at it?
Maybe, y equals 1x plus or minus 2.
Good. So I'm going to clear that out. Now I'm going to have y equals absolute value of x minus 2. So I just clicked right into that text box that was already there for me and changed it. And then hit enter to get out of it. Okay? So this is y equals the absolute value of x minus 2. The only thing that changed was where it was on this x-axis. The slope didn't change. It didn't change left and right. It only went up and down. Okay? So you're following this x-axis. So what is that value for C doing? How is it transforming your graph? Up and down, vertically. Does that make sense? Okay, we'll have to finish this lesson next time. You can do the majority of your homework. I think there may be 1 or 2 questions you might not be able to do. It's right on your calculator, weekly project due next time. Next class will be review. The class after that is your unit test.